Patterns in nature, shown with points and lines. We often overlook points and lines because they look so simple. But when we face a scene that is hard to understand at a glance, we start with those simple things first. In these moments, mathematics does not force objects to change. Instead, mathematics changes the way we express objects so we can see them differently. So we begin by placing points and connecting them with lines, figuring out what is where and what is close to what. In mathematics, a point is a position with no size, and a line is a connection with no width. In the real world, we cannot see these kinds of points and lines. For convenience, we draw points small and lines thin to help us think. What matters is not the shape, but the relationships. The arrangement of points, including their positions, how far apart they are, and how they come together, creates a pattern. When points are close together, it feels as if something is gathering quickly. When they are far apart, everything looks more spread out. When we make the points a little bigger or smaller, we might even get the illusion that they are moving closer or farther away. Even when the points do not move, we can see movement in their arrangement. This is because our eyes quickly begin to look for meaning when points come together. The sky is like a canvas where points spread their patterns. The sun, which looks like a large point, rises from the east every day and sets in the west. The stars in the night sky use their positions to form pictures called constellations. The constellations we notice change with the seasons, but every year we see the same familiar stars again. Living things also carry patterns in their spots. The spots of leopards and cheetahs help them blend into their surroundings. The motif on a ladybug can also be a warning that says, "Do not try to eat me." In nature, a motif is often not decoration, but function. When we look inside cells, the patterns become even clearer. Let us think of one cell as one point. Then, the arrangement of points is different in each organ. In places like the small intestine or lungs, where exchange is important, the points spread out in thin, wide layers. In places like the skin, which need to protect, the points are stacked closely in many layers. In blood vessels and the esophagus, where movement is important, the points are arranged in cylinder-like shapes. In the brain and nervous system, which must send information far away, the points stretch out or connect like a net. Through the arrangement of points, we can see again that when structure changes, function changes. If a point is a place, then a line is a relationship. A horizontal line gives a sense of balance and calm. A vertical line gives a feeling of strength and tension. A diagonal line gives a sense of speed and tension because it is tilted. When rain falls at an angle, it feels heavier because of that sense of tilt. But in nature, we can find more curves than straight lines. Even the horizon, which looks straight from far away, is actually a gentle curve that follows the Earth's curvature. Some curves flow freely without rules, and others are shaped by rules. The path of a thrown ball forms a parabola, and movements in the sky trace the shape of an ellipse. A curve is a gentle line, and it is also a trace of rules. Points organize position, and lines reveal relationships. This is why, when we first try to understand patterns in nature, mathematics begins with points and lines.